Hello everyone, Arash Jafarzadeh here. This video is an introduction to programming concepts, basics, and data structures for JavaScript. I have divided this video into three parts. In part one, we're going to be looking at the big overview by looking at the basic definitions and understanding programming in general. Then we're going to focus in a little bit and look at what object-oriented programming is and the basic concepts that exist there. And then we're really going to focus in and look at data structures and how those look like in JavaScript. So we'll start with the big overview and then kind of focus in as we go through the video. So let's start with part one. What's a computer program? Well, a computer program is simply a series of instructions that enable it to perform various tasks. So if I have a computer game I'm developing and I have Link here and I want to make Link walk to the right, well, I just have to give the computer the steps so that it can make Link walk to the right. It just needs some instructions on how to do that. Well, to give it those instructions, it would be helpful for us to understand, first of all, how the computer language works, but also understand how the computer is seeing the screen. For example, the computer sees your screen as a big X and Y axis, where the X axis in the bottom left corner, if this whole thing was my screen, the bottom left corner would be 0, and as we progress to the right, each pixel is 1 unit on this X axis, and we go all the way to the right. Now in this example, it's 10, 20, 30, 40, 50, and I apologize for the black color there that makes it difficult to see on the dark background, but as we go across the X axis, the value increases to the right. And if we go up, it's a little bit different. What I mean by that is the y-axis, a traditional y-axis would be, 1, 2, 3, 4 all the way up, but a y-axis on the computer is flipped. So 0, 0 would be at the top, and then as I go down, that value increases. So 0, 0, 0 on the x-axis, 0 on the y-axis would be here, and then as I go down, that value increases for the y-axis, and as I go to the right, the value increases on the x-axis. Well, let's put our sprite on the screen. That's Link right there, and we want to make Link walk to the right. How do we represent that in terms of a coding language or programming language or as a formula? Well, it's going to involve a little bit of math, and what I mean by that is we're going to make a little statement here. Link's new location is equal to Link's current location plus Link's speed. So let's take a look at this. Let's say Link's speed is 10. So every time we see Link's speed, we know that value is always going to be 10. Link's current location is right here, and he is on 10 as well. So 10 plus 10 is equal to 20. So Link's new location is going to be 20. So in the next frame, Link is going to go to 20. Now, Link's current location is 20. 20 plus 10 is 30. So in the next frame, he's going to go to 30. Link's current location is 30. 30 plus 10 is 40. Then he's going to go to 40, and so on. So each frame he moves forward by 10, making it appear as though he's walking across. If you add a little animation, a walk cycle animation, it actually looks like he is walking instead of sliding. If I want to make Link move to the left, very simply, we just flip that plus to a minus, and Link goes to the left. So that's the main idea. We've really simplified it here, but that's the idea. A key word that you'll hear often in programming is the term algorithm. And an algorithm is simply a series of steps or instructions to perform a task or to solve a problem in a program. So whenever you hear someone say, oh, we need an algorithm for this, all they're saying is we need some steps to solve this problem or to do a task. For example, let's say I want to make a peanut butter and jelly sandwich. Step 1, I would write the algorithm or the steps as get the bread, get the peanut butter and jelly, spread the peanut butter and jelly on slices of bread, put the slices together, and enjoy. That's the basic idea. We're just giving a series of steps. And when we say algorithm, we're also implying an order. So this order of the steps also matter. You can't just, mix the steps up and expect the same result. I can't put the bread together, then get the bread, then cut the bread, then get the, yes, it just doesn't work. So keep that in mind, that you have to also consider the order of the steps when you're making an algorithm. A computer program is the implementation of an algorithm or algorithms to solve problems. So a computer program is made up of algorithms. One thing I like to talk about also is going beyond coding. What I mean by that is when we often hear about, coding, and coding is important and we have to teach coding, but when we say coding, a coder can usually translate logic into code. You can put together a simple program, and you can probably code without having a grasp of programming foundations. But when we say a programmer's mindset, or we look at computational thinking, there's a lot more. And you are a programmer. You're If you're working on a big project, if first of all, whenever you're developing that project, it's going to take a lot of planning. Before you even start typing code or typing up your program, you have to plan. And then once you start planning and you're going through that process, you're going to have to break down problems into smaller components and use abstraction to accomplish your goal, how you're going to reach your goal. And then from there, you're going to need to, in order to do that, you're going to need to link other subjects. Depending on what type of program you're writing, you're often using math, you might be using physics, engineering. Programming may involve a lot of creativity. And of course, how much of each of these topics you may use are dependent on what project you're working on. For example, if I'm making a platformer game, well, it's going to involve a lot of math and physics, because literally you're making a virtual world that has rules and laws, and things fall to the ground and things bounce off the walls and slip and slide. So it would require some physics and math. Engineering projects, when it comes into the physical world, are also often applied, or maybe you're making a simulation. So really, there's just so many things it can link to that it's really remarkable. Programmers also have to go beyond the obvious. They have to pay attention to the technical specifications, available memory, speed, and much more. It also often involves collaboration and teamwork. You have to work in a group to divide the responsibilities and come together to make the final product. Programming involves being organized. You have to write highly organized, clean, clear, quality code and include comments everywhere, so that when your teammates are looking at your code, they know where you left off, or what your intention was, or why you're doing one thing one way or not the other way, etc. So these skills don't just apply to programming. They don't just apply to someone learning coding. They can also be helpful in other parts of life, from solving problems to understanding logic, and understanding this tool that is so essential in the 21st century. Part two is us zooming in a little bit about the specific type of programming that is quite popular, which is object-oriented programming. So let's take a look at what that means. The way object-oriented programming works is you're kind of taking things and breaking them up into their individual components. So for example, in this lamp here, if I was to break it into its individual components, I'd have the base, I'd have the shade, and I have the light bulb. And when I bring these all together, I'm going to have light. If I look at them individually, I don't have light. It's the combination of them together that make light happen. There was a bell there. If something goes wrong, let's say my light suddenly stops working, don't have to chuck the entire thing, because I can just replace the bulb with a new bulb, or solve the problem with the bulb, and then I have light again. So that's like the kind of the big mindset. In object-oriented programming, everything works like an assembly line. assembly line. All of the parts may do very different things, and they may have different levels of complexity, but when we add them all together, they create the final product. So some of the concepts in object-oriented programming include the concept of class. And a class defines the characteristics of an object. The class, I always like the example of it's like a big dictionary, and it has a lot of helpful information there that you can use as the programmer. So some of the things that a class includes are characteristics, and characteristics are attributes and behaviors. So attributes, if I was looking at a car, let's say the class, I have this class called car, and the attributes might be the year that car was made, the make of the car, the model of the car, the color of the car, the type of engine in the car. Those are the attributes or the properties of the class. Behaviors or operations are what the class, what the object can do. So when we are looking at a car, well, a car can turn on, it can turn off, it can accelerate, it can decelerate, it can turn. Those are the behaviors that are defined in the class. So in our example of car, the properties would kind of describe the car, and the behaviors describe what the car can do. An object is an instance of a class. Creating an object is also known as an instance. So what that means is, in our example of car, well, car is the class. Now, if I make an instance of the car, maybe I'll have a car called My Mustang. Well, that object now, that instance, can use all of the information from the class to know what it can do. So the class is car, but my Mustang would be an instance of the class or the object. I can have multiple objects from the same class. So I can have my Mustang and have another class called, I don't know, my Mustang 2 or my Civic or whatever. They're all instances of the same class. And all I would do is, okay, well, maybe the Mustang may have, I may update or define how fast it can go versus the Civic, but they're both from the class of car. A method is the behavior of an object. So within a program, a method usually would only affect one particular object, not the entire class. So for example, if I have a class of car, and in that example, we said that, okay, well, the car can accelerate. If I make my Mustang accelerate, it's not going to make my Civic accelerate too. It will only affect that specific instance. There's also a concept in object-oriented programming called message passing. This is a process where an object sends data to another object or asks that object to perform a method. So for example, if I have a user, a driver object called Nicole, and Nicole is of the class driver, an instance of the class driver, I can have the driver push gas and the Mustang will accelerate. So all I would need to do is say, you know, once that happens, the my Mustang.accelerate sends a message to my Mustang, the car, and causes it to accelerate. That's the concept of message passing. Another concept is called encapsulation, and simply that just means that it's where we're combining many instructions into a single area or line of code. So in the example of Mario here, the encapsulated code for Mario would be Mario can walk, Mario can jump, Mario can duck, Mario can look up, etc. Now let's kind of hone in to JavaScript specifically and look at some data structures that exist with JavaScript. There's something called data types, and data types that are most commonly used with JavaScript are strings, numbers, and booleans. Now I'm going to go into some more detail about floats and integers, etc. But really, it's just strings, numbers, and booleans. So when we look at these common data types, these are the common ones we would probably use. There's others. Let's take a look at what they specifically mean. So the data type string is any series of characters in between quotation marks. So on the right, if I have hello in quotation marks, that is a string. How are you in quotation marks is a string. 235 in quotation marks is a string. So even if I type numbers inside the string, inside the quotations, it will not look at that as a number. It'll look at that as a series of characters of 235. A number is really cool because we can apply math to them, we can divide them and multiply them and square them, and all kinds of mathematical operations. And you'll use these a lot when it comes to programming. Numbers can be whole, they can have decimals. Different programming languages declare them in different ways. So here I have 235, it could be a negative number, it could be a floating point number, it could be a decimal, etc. So some languages require you to specify what type you're declaring, but JavaScript kind of puts all those, for the most part, into a number. But if you put in, if you type in, you'll see this later, but if I type in just like a decimal, it'll figure out automatically that I am working with decimals. So we'll get into more details about that in a little bit. And then we have Booleans. Booleans can be represented by one of two values. They can either be true or false. Some languages have a null value, but really Booleans are either true or false. And that's pretty much it. Those are Booleans. And then integers, really in JavaScript, we're looking at numbers, so you're not working too much with this. But if you hear the term integer in programming in general, they're talking about whole numbers. Skip that there. Not too relevant for us in our case. And then, those are the primitive data types. Now, there's a key word I want to bring up, which is called concatenate. And you're going to use this a bit as well. So when you're concatenating, you're dealing with strings. So we're going to go back to the string idea. Remember, those are the things that are in quotations. So if I take one string and I add it to the other, I am concatenating them. I'm sticking them together. So for example, if I have rock plus star in quotations, I get rock star. So that's the main idea with concatenation. So sometimes we may be combining things together with strings. Operators are symbols used to perform logical and mathematical operations. So for example, if I have a logical operator, for example, or, that would be represented by these two lines here. And if I want to say this and something, then I would use two ampersands. If I want to say not, I would use this exclamation point. These are logical operators. Mathematical operators include adding, subtracting, dividing, multiplying, or taking a percent of something. Relational operators are when we're comparing values to one another. So if I put a double equal sign, I'm comparing what's on the left side to what's on the right side and seeing if they're equal. There's greater than, there's less than, there's not equal to, there's greater than or equal to, less than or equal to. There's also a triple equal sign, which I didn't put here. Triple equal sign compares the values and their data type, but that's not on here, but that does exist. Assignment operators are when I'm assigning a value to something. So equal obviously sets the value of whatever's on the left to whatever's on the right. Plus equals adds whatever is on the left to whatever's on the right. Minus equals is the same as plus equals, except with a subtraction. Times equals, divide equals, same concept. Multiplying the thing on the left by the thing on the right and setting the value of the thing on the left to whatever the result is. And then the increment and decrement operators add 1 to something, subtract 1 to something. That's all that means. So there's all the main operators. Variables are super helpful in programming. Variables allow us to store values in memory. With variables, they allow us to store values in our computer's memory, and we can use it throughout our program. With variables, you have to declare or initialize them to work, and variables have a name and a data type. So for example, if I wanted to declare a string variable, I can make a variable called some string, and set its value to I love programming in quotations with a semicolon to stop or end that statement. So JavaScript is interesting because I don't have to specify the data type. I don't have to say some string colon, string for it to know that I'm making a string. Some languages do require it. This one doesn't, because it looks at it and it's like, oh, this is in quotations. This is obviously a string. If I wanted to initialize a number variable, I just type in var some int or some number, whatever I want to call it. This is just the name you make up, equals 23.5 or whatever value, and then put a semicolon. And now whenever I say some int, it knows that means 23.5. If I want to make a Boolean, I would type in var some Boolean or some whatever name I want. Var, frogs is equal to true. And now that is declared as a Boolean. With floats, you just type in the value, and again, JavaScript figures it out for you. Camel casing is also a term used in programming. Camel casing simply means that when we're declaring our variables or making names for things, we can't make spaces. So for example, in the previous slide, you saw I wrote like some string. Well, I can't make it some space string. It has to be all one word. And then typically you would capitalize the second word and so on, the first letter of the second word or third word, etc. So that way it's just visually easier to tell. It's just a programming convention. And that's called camel casing when you do that. So it just kind of helps you keep track of things, because typically the capitalization of words matter. If you don't capitalize it one place and you capitalize it another place, it won't know what you're talking about. So that's camel casing. Here is a variable broken down. Now I purposefully included the data type here, but JavaScript you don't have to do this. But in some languages you do need to do this, including perhaps another language we're going to be learning later this semester. So I just included it so you can see it. But if we were to break this down, var means variable, and it's just initializing the variable. The name, this is the name of the variable. This is the identifier. So when you put a colon there, you're identifying this as whatever's on the right, which is the data type here, number. And then this is the assignment operation, the value, and this is the break. There's also a concept in programming called an array. An array is an object that stores multiple values. So for example, here I have a single dimensional array called food. And oh, that should be a var there. So that's a little typo there. Ignore that. That should say var. But yeah, so var, food equals, and then in brackets, I would put the 3 items separated by comma. So this is going to be a pizza, and then we have cake and berry. And so in the position 0 of my array, I have pizza. In position 1, I have cake. And position 2, I have berry. It's just 3 items. It starts with 0, and then we go on. My value, again, it's just a var. Var my value, or let my values equal, and then in brackets, I put the values in there, and we have 3 numbers in this array, starting from 0 being 30, 1 being 27, and 10 being, 2 being 10. Another important concept in programming are control statements. And let's take a look at what those mean. So conditional statements, also known as if statements, allow us to test a variable against a value and act one way if the condition is met and another way if it is not met. So if some value is, or if some condition is true, it does one thing. If it's not true, it does something else. So here's what a conditional might look like in JavaScript. I put if, and then in parentheses, I put the condition. Some num is greater than 20. Let's say some num is 10. If it's greater than 20, it would say console.log, and then it would just type this in the console in the kind of output window. X is greater than 20. It would type that out for us if some num was greater than 20, which it's not. So it's going to do the else, and in all other cases, it's going to say x is less than or equal to 20. In this case, if some num is greater than 20, it's going to do the same thing, but we also have an else if. So the way this works is, if the condition is met, it does one thing. Done. If that condition is not met, it goes here. Else if this other condition, if that's met, it does one thing. And if that's not met, it does another thing. And if that condition is met, it does one thing, and then so on. So that's a if, else, if type of statement. We have if, else statements where it's like if a condition is met, it does one thing. If it's not met, it goes here. And it's like otherwise, if this other condition is met, it does something. And if that's not met, in all other cases, it does something else. So we have if, else, ifs, and if, else, if, else's. I think I got that. Very important concept of loop. You use these quite a bit as well. A loop is a sequence of instructions that is continually repeated until a certain condition is met. There are different types of loops, like for loops and while loops. You'll learn those as well as we go. This is an example of a for loop. In a for loop, I said, I initialize this variable called I. I is set to 0. As long as I is less than 5, keep looping and iterate, add 1 to I after each loop. So the first time, if I is equal to 0, it's going to set I as 0, and then it's going to check to see if I is less than 5. And so I is 0, so 0 is less than 5. So it's going to go through the loop and do whatever we want it to do. And then it's going to add 1 to 0. So is now 0, or I is 1. So it's going to check again. Is 1 less than 5? If it is, it's going to do it again and add 1 to I. Then it's going to do it again. Now we have 2. Is 2 less than 5? Yes. And then it's going to do it again. 3 less than 5, 4 less than 5. And then when it's 5, 5 is not less than 5. So then it's going to stop the loop. This visual kind of represents that. We're getting to the end here. Keyword iteration. Iteration is the technique of marking out a block of statements within a program for a defined number of repetitions. So in our example of that loop, each time we went through that loop, it was one iteration. Functions are combining many instructions into one place. So here we have a function called do something, and whenever we call on the function, whenever we say do something, it's going to go through the steps within the function. So you can have many steps. There are some functions that allow us to pass information into them, and then they output something. So here you can see I put an empty parentheses here because I'm not passing anything into the function. But if I was to put something in these parentheses, I am passing in some parameters into the function. It does something to them and then spits out a value for us. An event handler, also known as an event listener, is also a program we're going to be using, a concept we're going to be using. It's a routine that is used to deal with an event and allows the programmer to write code that's going to be executed when the event occurs. So the way that works is I can have an event source, let's say a button, which is typical. So I have a button, that's my event source, and then I have an event. So the button gets clicked, or the button gets hovered over, or when the button is released, that's the event. And then response is what the program does when that button is released. Typically, this would be a function. So the event source would be a button. When I press the button, do a function called whatever. Concept of recursion, it stems from math and it means defining a problem in terms of itself. Recursion is the process of defining a problem or the solution to a problem in terms of a simpler version of itself. If you are home, stand still. If you're at home, stand still. Take one step towards home. Find your way home. So this is kind of like a concept of a recursive algorithm. There's also recursive functions. And last but not least, let's talk about pseudocode. And pseudocode is a notation resembling simplified programming language. So in programming, sometimes you don't want to just start coding, right? You want to plan ahead. And so you can write out the the steps in your code or the idea in your code as a list. You can write it out, but it's not actual code. It's just like the steps. Like I would write out if x is greater than 5, do this or that. I'm writing it out, but I don't actually have to use the syntax necessarily. And it's just there for planning. I really like to use flowcharts as well. So flowcharts, same concept. Each of these shapes represent a different part of the program, just to make it more easily to recognize because it's visual. So you can also make flowcharts as well. There are some great apps that you can use. Microsoft Visio is great, for example, or you can also just draw it out on graph paper. So I think that is it. I hope this introduction to programming is helpful for you, and looking forward to actually developing some programs together. See you next time.